Okay, this is 4.6, formalizing relations and functions. We have some vocabulary here. We'll start with a relation. A relation is a pairing of numbers with domain and range. So a relation would be something like, here's what I mean by pairing of numbers. Fancy bracket. We've got some coordinates in here, maybe 3, 2, 4, 5, -2, 0. There's 3 coordinates in there. We would just plot those 3 points. That's known as a relation. It's just a set of points. You could plot it on a coordinate grid. The domain is the set of independent variable values, or another way to think of that is the first coordinates. So the domain it's just a listing of the first coordinates in order, typically. So we might do something like this, fancy bracket. In this case, -2 would come first, and then 3, and then 4. It's just listing the first coordinates in order from smallest to biggest. The range would be the set of dependent variables, or the second coordinates. So you might think of that as the second coordinates. Just a listing of the second coordinates, all in order from smallest to biggest. So if I did that, I'd start with 0 as the smallest second coordinate. 2 is the next one, and then 5. So 0, 2, and 5. It's a listing of the range. So we have domain, range, vertical line test. So say you plot these 3 points here, the relation. If you want to decide if the relation is a function or not, a function is a special case of a relation, you can use the vertical line test. It says if any vertical line, so if you can draw any vertical line that passes through a graph more than once, passes through more than one point, then it is not a function. What I mean by that is if you have a graph grid like this, you have some points plotted on here, maybe one here, one here, one here, you'd see that there's no vertical line I can draw that's going to go through more than one point. There's no case where there's one point stacked directly above or below one of these 3 points. But if I do this, add that green point in there, now there is a vertical line going through the blue and the green point. It makes that not a function. So if you ever have one point stacked on top of another, it is not a function. You can quickly and easily see that by drawing the graph, and I'll show you one other way to do that as well. Function notation. F of x, it's not f times x, it's read as f of x, it replaces y. It's just matter of taking something like y equals 3x plus 1, replacing it with f of x equals 3x plus 1, or g of x equals 3x plus 1. We use this oftentimes in mathematical modeling, science and math, where sometimes we might have a variable like t, and you want to represent velocity at a certain time. You might have v of t, and it just tells you to plug in a number for x in the function. So for example here, if I had f of 3 here would be 3 times 3 plus 1. It's just telling me plug in 3 for x in the function that was given to me. So this is 9 plus 1, or 10. You could change up the function. You could call it g of x. In this case, let's find g of -3. So g of -3 would be 3 times, I plug in -3 for x, plus 1, which is -9 plus 1, is -8. It's just a way to let functions represent specific things in real life, oftentimes, and tell us, okay, plug in different values for x, evaluate this function at different places, use it to predict. So that's function notation. So I'm just asking you with f of 3 to plug in 3 for x, or g of -3 is plug in -3 for x and evaluate it. All right, identifying functions using mapping diagrams here. We have identify the domain and range of each relation. Represent the relations with a mapping diagram. Is the relation a function? So mapping diagram looks like this. You have a domain and a range, an oval for each. We're going to list our domain in the first oval, and we're going to list it in order. So our domain are the x-coordinates. We're going to list them in order. So I'll circle the x-coordinates, or first coordinates, I should say. They're not necessarily x-coordinates. So we have -2, 0, 4, and 5. And then let's go ahead and identify the range. I have 2.5, 6.5, another 2.5, and 0.5. I only need to list each value once. So there's 0.5, there's 2.5, and there is 6.5. Notice I'm not listing the 2.5 twice. Then I'm going to draw an arrow that matches each first coordinate with its second coordinate. So -2 goes with 0.5, 0 goes with 2.5, 4 goes with 6.5, and 5 goes with 2.5. And so if I were, just going back to the vertical line test, to plot these points, I have -2 and 0.5. So let's just say that's right there. I have 0 and 2.5. That might be somewhere up here. Got a point up there, a point here, and then 4, 6.5 might be higher up. So 1, 2, 3, 4, 5. 6.5 would be well up above that. So 1, 2, 3, 4, 6.5, maybe somewhere up here. See that up there above the 4. And then 5 over, 5 over 2.5. So 1, 2, 3, 4, 5, 2.5. So what you'll notice is if you look at these points here, 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 and here, there is no one point stacked above another. So you can, this is probably the easiest way to do it, is just picture this. Draw the graph or picture the graph and see if there's anything one above the other. What we'll notice is if we have one above the others, we'll see as we look through this list here of first coordinates, first coordinates that are the same and their y coordinates are different. And that's not the case here. We have all 4 different ones. We do see that there are 2 horizontally. This one right here and this one right here are horizontally on the same line, but vertically they're not. So this one, it says, is the relation a function? Yes, this is a function. So that one is a function. I'll show you when I do this next one kind of a comparison of the 2 mapping diagrams. You can tell from the mapping diagram as well. So let's see here. Let's move these coordinates over. We'll draw another mapping diagram here. I have domain and range. So the domain, let's circle them. There's 4 numbers, so if I go in order, it's 4, 5, and 6. Notice the 4 shows up twice, or the 6 shows up twice, right? And here the range is 5, 3, 4, 8. So if I put them in order, it's 3, 4, 5, 8. And as I draw this mapping diagram, 6 goes to 5, 4 goes to 3, 6 again goes to 4. There's the key right there. I have 2 branches coming from the same first coordinate. That makes it not a function. And then finally 5 goes to 8. But if you see 2 branches going from the same x value, what's going to happen, or to draw a picture, is I will have one point stacked on top of another. 6, 4, and 6, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So 6, 4 would be right here. A different color, and 6, 5 would be directly above it right there. It's not going to pass the vertical line test, and so this is not a function. So it's not a function. This one, yes, it is a function. So over here you can see that there are no 2 branches going from the same first coordinate or domain coordinate, so we're okay there. So when you see this little scenario right here, it's not a function. Most students like the vertical line test as their way of deciding if something's a function. It's really visual, easy to see. It says here are 2 graphs here. It says, is the relation a function or not? So we're looking through this, looking for a scenario like this. Oh, very good vertical line. Let's try that again. This vertical line passes through more than one point, so this is not a function. Whereas on the other graph here, I don't see any points where there's one line stacked above or below another. So this one is a function. So mapping diagram, one way to arrange your domain and range, list the domain and range, and then also decide if it's a function or not. Then also to plot the points. All right, evaluating a function. It says the function w of x equals 250x represents the number of words you can read in x minutes. How many words can you read in 8 minutes? This is an example of w represents words. X is the time, so we're asking for w of 8, which is 250 times 8. And we just do the multiplication. That's 1,600 and 400. That's 2,000. In 8 minutes, you can read 2,000 words. So 2,000 words. Right. Next one says finding the range of a function. The domain of f of x equals negative 1.5x plus 4 is 1, 2, 3, 4. What is the range? Well, we find the range by evaluating this function at 1, and then at 2, and then at 3, and then at 4. That will give me the range. So first plugging in 1, it's negative 1.5 times 1 plus 4. Negative 1.5 times 1 is negative 1.5, plus 4 is 2.5. Negative 1.5 times 2 plus 4, that's negative 3 plus 4, which is 1. And negative 1.5 times 3 plus 4, that's negative 4.5 plus 4, which is negative 0.5. And then we have negative 1.5 times 4 plus 4. That's negative 6 plus 4, which is negative 2. So my range, sometimes we'll abbreviate it just with an R, colon, and then fancy brackets. We go from a low value of negative 2 up to negative 0.5, and to 1, and then to 2.5. So we're not asking for range like in statistics where you're listing the length or distance between the max and the minimum, but we're listing all of the values that you get as second coordinates or y coordinates or outputs for the given inputs. And so we're listing those in order from smallest to biggest.